Hello, welcome to the video. In this lesson, we're looking at section 10.6, where we're going to be looking at binomial distribution. So in this section, we are going to look at not only how many possible solutions there are in a sample set, but also we're going to look at the frequency of a particular outcome will be in an event. So the first part here is talking about, it says a probability distribution is a function that gives the probability of each possible value of a random variable. So on the bottom is looking at the distribution of rolling a six-sided dice. So you can either get a 1, a 2, a 3, or 4, or 5, or 6. The bottom number is the probability of you landing on that said 1, 2, 3, 4, and 5, 6. All of them are 1 out of 6. The idea is that if you were to add up all of those values together, you would equal out a value of 1. So to give you some examples in this, it says let x be a random variable that represents the sum of when two dices are rolled. They want us to make a table, and then they want us to draw a histogram showing the probability distribution. Okay, so we know from past lessons that if we roll two six-sided dice, we are going to get 36 outcomes. That comes from, the first one, we have 6 possible outcomes times by 6. So 6 times 6 is 36. What we want to look at now is the probability of what the sums are going to be when we roll these two dices. So the smallest sum that we could get is 2, because 1 plus 1 is 2. And the largest sum that we could get is 12, because 6 plus 6 is 12. So then we can get a sum of anything in between that. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so these are all the sums that you're going to get when you roll a two-sided or six-sided dice. The question is we want to make what is a frequency table on how many of these 36 possible outcomes, what are the sums going to be? Well, I know that there's only one choice where you get a sum of 2, and you only get one choice where you get a sum of 12. 1 plus 1, rolling a 1 gets you a 2, and rolling a 6 gets you a 12. But what you get now, as we start getting towards the middle, you get more possible outcomes, more possible frequencies. So there are 2 opportunities for getting a 3. There's 2 opportunities for getting 11. There's going to be 3 opportunities for getting a 4, 3 for 10. There's going to be 4 chances at a sum of 5, 4 chances at a sum of 9. We got 5 chances for a sum of 6, 5 chances for a sum of 8, and 6 chances at a sum of 7. If you were to add up all of these values, you should get 36. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 4 plus I'm sorry, 5 plus 4 plus 3 plus 2 plus 1. If you add all those together, you should get 36. Then what we can do is, knowing that there are 36 possible outcomes, we can now have a probability. So the probability of us getting a sum of 2 is 1 out of 36. It's also the probability of us getting a 12. What's the probability of us getting a 3? Well, it's 2 out of 36, or 1 out of 18. Same thing goes over here. 1 out of 18. For the sum of a 4 is 3 out of 36, which is 1 out of 12. That's what it would be over here for a 10. For to roll a sum of 5 is 1 out of 9. It would be that over here. To roll a sum of 6 would be 5 out of 36. This would be 5 out of 36. And for 6, it would be 1 of 6. The last thing here, it says draw a histogram. So if you know about drawing a histogram, it's like a bar graph with no spaces in between them. So on the bottom is going to be the frequencies, so are the sums. So this is what, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then this is the fractional probability. So if I wrote like this was like 1 out of 18, 1 out of 9, and we'll say like 1 out of 6. All right, so here it's like 1 out of 36, so it's going to be here. 1 out of 18 for 3 is right there. 1 out of 12 for 4 is right there. 1 out of 9 is right there. 5 out of 36 is in between. 7 is 1 out of 6. This is basically, now it's just going to be like a mirrored image running all the way down. And that is like my histogram for these, for the probability of us rolling 2 6-sided dices. So here, they want you to do a similar thing, but they want us to make, we're looking at 8-sided dice. So let's see here, we roll. It says an octagonal dice has 8 sides, numbers 1 through 8. It says let the probability win the sum. So we're looking at 2 8-sided dices. So in this particular instance, your ranges are between 2 and 16. So you can go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So just like I did with the 6-sided, you are going to hopefully realize that 8 times 8, there's 64 possible outcomes. And just like what we did here, there's going to be 1 outcomes for the outside, and then it increases from there. So this is going to be 2 and 2, 3 and 3, 4, 4, 5, 5, 6 and 6, 7, 7, and then we got 8 in the middle. And then the probability of all of these, so I'll just making another chart here. So the bottom, the outside ones have a 1 in 64 chance. And remember that the number of that number that I put here, 1, 2, 3, 4, whatever that is, that's how of the 64, that's how many chances it has of getting that sum. So we got 1 out of 32 over here. We got 3 out of 64 over here. This one will be 1/16. The next one is 5 out of 64. The next one is 3 out of 32. The next one is 7 out of 64. And for a sum of 9, it would be what? What, 1/8? Then now it starts in the repeats. So now it's 7 out of 64, 3 out of 32, 5 out of 64, 1 out of 16, 3 out of 64, and then finally 1 out of 32 over here. So these are all the different probabilities. I'm not going to draw the histogram. If you want to see the histogram, it's very similar to the one I just did. Um, for answering question number 2, it says, what is the most likely sum? Well, it's the one that has the most frequency. In that case, it would be rolling a 9, a sum of 9. And then they're asking is, what is the probability that the sum of the two dices is at most 3? So basically you're looking at, so at most 3, so it's either going to, they want to know if it's either going to be a 3 or a 2. So basically what I'm going to do is you just take the probability of you getting a sum of 2, which is 1 out of 64, and add it by the sum of 3, which is 1 out of 32, and that is going to equal 3 out of 64. So you have a 3 out of 64 chance of you getting a sum of dice that's at most 3. The second portion of this lesson is talking about being able to determine what is called a binomial experiment, um, which meets the following conditions. It says there are n independent trials. Each trial has only 2 possible outcomes, so either success or failure. And then the probability of success is the same for each trial. This probability is denoted by P. The probability of failure is 1 minus P, same thing as like the probability of it not happening, kind of like that. For a binomial experiment, the probability of exactly K successes in N trials is formulated by this formula, where you have the combination formula where you have N trials over K successes times it by the probability of K, and then it's going to be 1 minus P, which is not successes, and that's where you have N minus K. So this is the the successes, and then this is dealing with the failures. So for instance, it says according to a survey, about 33% of people ages 16 and older in the US own an electronic book reading device, or an e-reader, kind of like a Kindle. You ask 6 randomly chosen people ages 16 and older whether they own an e-reader, and they want you to draw a histogram of the binomial distribution for your survey. Okay, so what you can say is you can ask 6 people, and essentially you're going to get 7 outcomes. All right, so of the 6 people you asked, they can say that of them that zero people own the e-reader, 1, 2, 3, 4, 5, or 6. So those are the possible successes. So you can either have 0 people that said it, 2, 3, all the way up to 6. So here is how we're going to determine the probability of that. To determine the probability of you getting 0 people, or 6 of the 6 randomly chosen people, you got 0 people that said they own some type of electronic book. What you're going to do is you're going to look at the combination of, in this case, how many people were randomly chosen. Well, in this case, it's 6. How many people said that they did? In this case, it was 0. And you're going to multiply it by the number of successes. They say that 33% of people, that's what the survey says. So now you're going to convert that to a decimal and say this is going to be 0.33, and you're going to raise it to the 0 power. The reason why you're raising it to the 0 power is because in that particular choice, 0 people showed it. That means that there is a 67% chance that they didn't. So, and then that's going to be raised to the 6 power. So once you've calculated this combination formula and multiply all of this out, you are going to get a result of 0.090, which means you have like a 9% chance of this happening. All right, so now if we looked at one one of those people being chosen, so that means now we're going to look at a combination where we surveyed 6 people and one of them said yes. So now of the 0.33% from a survey, you're going to be raising this to the 1 power, because in this particular instance, one person said that they did, which meant that 5 people would be under the 0.67. So if you do all the math for this, this turns out to be 0.267. So in this case, you'd have like a 26.7% chance of this occurring. Looking at 2, so now you got C is 6 and 2. I'm just going to do this. So now this is going to be C6 and 3. This is C6 and 4. This is C6 and 5. And then finally, this is C6 and 6. I don't know why I put a 6 here. Okay. And then here, this is going to be 0.33. This one's going to be the second. This is going to be 0.33 to the third, 0.33 to the fourth, 0.33 to the fifth, 0.33 to the sixth. Looking at failures, this is going to be 0.67 to the fourth, 0.67 to the third, 0.67 to the second, 0.67 to the first, and 0.67 raised to the 0 power. So those are where those formulas come from. Now, doing all of the calculations, the probability of 2 of the 6 saying yes would be the 0.329, where 3 of them would say yes. After all the calculations, it would be about 0.216. For 4, it would be 0.080. For 5, it would be 0.016. And for 10, and for 6, should be 0.001. So that's what you get for that. The highest probability would be right here, which would be 2, which would make sense. And I guess I just answered this question here. So it says, use the binomial distribution example 3 to help answer. It says, which is the most likely outcome? And the most likely outcome, I just answered that. That was 2. Over here, it says, for part B, it says, what is the probability that at most two people have e-readers? So what you're going to do is looking at the probability of like the k successes is less than or equal to 2 because it's at most 2, so it's like 2, 1, or 0. So how you determine that is you look at those values of probability values of 2, 1, and 0. So this is 2, this is 1, this is 0. You're just going to add those together to get the probability of them being at most 2. So you would get 0.090, add that to 0.267, and then you add that to 0.329. When you add them all together, it's 0.686, so you'd have like a 68.6% chance of the probability of them being at most 2. And that is looking at binomial distribution. I hope this helps. Until next time.